Hello everyone, welcome back to the video series of signals and systems. So in this video we are going to learn about one of the important continuous time signal, that is sinc function. Sinc function or sampling function. Sinc function or sampling function. So if you are first time to my channel, please consider subscribing. Okay, so sinc function is sine over argument. Okay, so in simple we'll call it as sine over argument. It is decreasing amplitude sinusoidal signal. So decreasing amplitude sinusoidal signal. So maximum value of sinc function is obtained at origin, that is at t is equal to 0. So sinc function is generally represented as sinc x. It is represented as sinc x, or in sampling function it is represented as sa x. Sa of x, we'll call it as sa x. So sinc x is equal to sine pi x by pi x. So sinc x is called so it is represented mathematically as sinc x is equal to sine pi x by x. So this is sine over argument. So sine over argument, since x is there in the denominator, its amplitude always decreases with increase in x. Okay, or say sinc t as a signal will represent it as sine pi t by pi t. Okay, sine pi t by pi t. Similarly, sa of suppose we'll write it as t. Sa of t is equal to sine t divided by t. So this is sampling function, and this is called as sinc function. This is called sinc function, and this is sampling function. So if you draw them graphically, so this is sinc t versus t. Similarly, if you draw sa t versus t. Okay, so as I have told you, it is decreasing function of or decreasing amplitude of sinusoidal signal. So maximum amplitude is available at t is equal to 0. Similarly, on the negative side also we'll get the okay. So this is going to be sinc function. So this is how it is going to decrease in amplitude. Okay, so curvature must be smooth. Okay, so this is the sinc function. So here it is pi, 2 pi, 3 pi, so 4 pi, and so on. It is minus pi, minus 2 pi, minus 3 pi, minus 4 pi, and so on. Okay, so it extends up to infinity. So this is the sinc function. So sinc function is equal to 0 at t is equal to plus or minus n pi. So sinc function is equal to 0 at t is equal to plus or at t is equal to pi, its value 0, 2 pi value 0, 3 pi value 0. So minus pi minus 2 pi also, its value is going to be 0. So sinc function is equal to 0 at t is equal to plus or minus n pi. Okay, so this is about sinc function. If you want to draw the sa function, it is also same, decreasing amplitude of sinusoidal signal only. Okay, so the only difference here is, since there is no pi here, we'll write it as 1 2, 3, 4, and minus 1 here, minus 2, minus 3, minus 4, and so on. Okay, it extends up to infinity. Okay, so this is about sinc function or sampling function. So mainly it is decreasing amplitude of sinusoidal signal, and its value is equal to 0 at t is equal to plus or minus n pi. So if you want to represent it as sinc function, its value is sin pi x by pi x, and if you want to represent it as sampling function, its value is sin t by t. This is also sine over argument, so this also represents sine over argument, so it is also another form of sinc function. Okay, so these are the pictorial representations of sinc function and saw function respectively. Okay.